Hi, good afternoon, everyone. So, what I aim to go ahead and do today is wrap up the sequence part of sequence and series, right? So, we are going to talk about whatever leftover pieces are there in sequences, and we're going to finish off the part of sequences today. In order to begin with this, the first thing that I want to cover today, that is called as a monotone sequence. We want to understand what is a monotone sequence. So usually you would have heard the word monotone, and the meaning of monotone is anything which is strictly increasing or strictly decreasing. That is exactly what happens with sequence also. Any sequence which is strictly increasing or strictly decreasing, that is called as a monotone sequence. Again, let's take some example here. So for example, if I tell you an is equal to 1 by n, an is equal to 1 by n, and I start plugging in some values of n. So suppose we go ahead and we plug n as 1. So 1 divided by 1 will give me 1. So my n for n equal to 1 will be 1. Now I go ahead and I plug n as 2. So I will get 1 by 2, 0.5. Then I plug n as 3 and I will get 1 by 3, which means 0.33. Then I plug n as 4 and I will get 1 by 4, 0.25. I plug n as 5 and I will get 1 by 5, 0.20, and so on. Let's try to also plot this once. So when n is 1, I get the answer as 1. When n is 2, I get the answer as half. When n is 3, I get the answer as 1 by 3. When n is 4, I get the answer as 1 by 4. And so on. So you will notice that these terms, I cannot make it continuous. This is just for discrete n. But you will notice that these terms actually go closer and closer to 0. They approach 0. It means that it is a decreasing sequence. The values are decreasing in nature, right? So when we talk about a monotone sequence can be strictly increasing or strictly decreasing. There is another thing that I want to highlight here. Just because a sequence is strictly increasing or decreasing need not mean that it has to be a bounded sequence. Just for example, if I tell you that an is n, so this means what, beta? It means that if I go ahead and I plug n as 1, I will get my an as 1, right? If I have second term, if I want to find what my second term will be, I'll put 2 here and I will get 2. My third term will be 3. My fourth term will be 4. So of course, this is increasing. Of course, this is increasing in nature. But, but there is no upper bound, right? There is no upper bound, right? So just because a sequence is a monotone sequence does not mean that it will be bounded, right? Does not mean that its bound will exist. But, if a sequence is a monotone sequence, if a sequence is monotone and bounded, एक sequence है जो monotone है and it is also bounded. माने, what does it mean? It means that if this sequence is decreasing, it is bounded below. Lower bound हमें पता है. And upper bound तो हमें पता ही होगा, because that will be when n is plugged as 1. Similarly, if a sequence is increasing, again, lower bound I know in this case, that's the value when n is 1. I will get some value, that will be lower bound. But if it has some upper bound, if upper bound exists, if it is bounded above also, right? So if a sequence is bounded below and bounded above, man, it is bounded, right? So a monotone sequence, which is also bounded sequence, that basically goes ahead and becomes a convergent sequence. Because it is converging to some value, ना जिससे भी वो bounded below होगा या bounded above होगा, it would be converging to that value. So we can go ahead and we can say that yes, in fact, it is going to be a bounded sequence and therefore a convergent sequence. So this is important. Sometimes if I want to check if a sequence is converging or not, what I can go ahead and check is whether it is bounded plus whether it is monotone. If these two things are satisfied, then automatically the sequence will be a convergent sequence. Automatically a sequence will be a convergent sequence. But the reverse is not true. माने ऐसा नहीं है कि जो भी convergent sequence है उनका monotone होना जरूरी है. That's not true. So all convergent sequence may not be monotone. May not be monotone, right? So take an example. Suppose I go ahead and I draw a sequence which looks like this. 1 minus 1 to the power n upon n. So if I take n as 1, let's take a plus here for now. I'm just trying to create some sequence. So if I take n as 1, I will get the answer as 1 plus minus 1 to the power 1 upon 1. Now, let's take a negative sign only here. Okay, so this will give me 1 plus 1, that means 2. Now, let's say I take n as 2. I'll get 1 minus 1 to the power 2 by 2, 1 minus half, I'll get half. Now take n as 3. So I'll get 1 minus 1 to the power 3 by 3, 1 minus 1 by 3, 3 plus 1, 4 by 3. I'll just take one last term here to prove my point. So I'll take n as 4. So I'll get 1 minus 1 to the power 4 by 4, 1 minus 1 by 4, 3 by 4. Okay. And when you will take limit n tends to infinity, 1 minus 1 to the power n by n, जब ये निकालोगे, I am leaving it to you. You should get the answer as 1. Huh? We have already done limits. So you will get the answer as 1. Okay. Now, why will you get 1? Let me just do this for the sake. So, you know, when I say 1 minus 1 to the power n by n, देखो, if n is odd, अगर n एक odd number है, if n is odd, right? So we know that minus 1 to the power n is simply minus 1 because its power is odd. And if n is even, so we know minus 1 to the power n will be simply 1. So this thing that I have here, I can write this as 1 minus 1 by n if n is odd, and 1 minus 1 by n if n is even. तो दो अलग चीज आ गई कि n even होने पे क्या फंक्शन ले रहा है और n odd होने पे क्या फंक्शन ले रहा है. Now if I just take limit n tends to infinity, limit n tends to infinity, in both the cases, what will happen here? I'll get 1 minus 1 by infinity. Anything by infinity is 0. So I'll get the answer as 1. And here also if I plug this, I'll get 1 minus 1 by infinity, which means I will get 1 minus 0. That means 1. So whether n is odd or even, it will converge to 1 only. So this sequence will converge to 1. Okay. Now just try to understand what we are doing here. So if I try to go ahead and if I try to plot these points, right? So n1, n2, n3, n4. So when n is 1, I'm getting the answer as 2. So suppose somewhere here I have 2. This is 1. When n is 2, I'm getting the answer as half. That means here. When n is 3, I'm getting 4 by 3. 4 by 3 is 1.33, more than 1. So 4 by 3 can be somewhere here. When n is 4, I'm getting the answer as 3 by 4. That means 0.75. So 3 by 4 will be close to 1. So somewhere here. So you will notice that slowly the terms are becoming closer and closer to 1. The gap is reducing. देखो पहले gap इतना था, फिर gap कम हुआ, फिर gap और कम हुआ, फिर gap और कम हुआ. Slowly the gap is reducing. That means the corresponding numbers, they are approaching 1. But it is not an increasing sequence nor a decreasing sequence, right? You see that there are terms, the terms are going in an oscillating way. So neither it's an increasing sequence nor a decreasing sequence, but it's still converging to 1. So convergence अगर हो रहा है इसका मतलब ये नहीं है कि monotone होगा. But अगर monotone है, if it is increasing or decreasing and bounded, then we are sure that it will be a convergent sequence. Then we can go ahead and say that it will be convergent. That is what the thought process is here, right? Okay. Now let us go ahead and let us try to